Today we're going to be talking about carbon emissions globally. This recent report, the Statistical Review of World Energy, has just been released from the Energy Institute.
The video you're watching on the screen shows carbon emissions by country by year up until 2024, and it's made from this data released by the Energy Institute.
There's lots of excellent data in here that we'll be digging into, and we'll leave a link in the description so you can go and have a look for yourself. There's an awful lot of excellent data that has been released, so we might do some more videos. We could look at oil and gas production and consumption, or even dig into renewables. But in today's TROVE video, we'll be looking at carbon dioxide emissions. In 2024, there were 40,812 million tons of carbon dioxide equivalent emitted. And the emissions used here that we're talking about today are the sum of carbon dioxide emissions from energy, flaring, methane emissions associated with production, transportation, distribution of fossil fuels, and carbon dioxide emissions from industrial processes. So it's essentially all carbon emissions directly related to humans. Doesn't include stuff like deforestation and other less direct sources. And it's made up of 82 countries that are included, and we'll be looking primarily at data from 1990 up to 2024. So the headline, we're all talking about reducing our carbon emissions. However, they keep rising. This is looking at global emissions from 1990 right through to 2024. You might notice that there's a couple of dips in this, and we'll break this out into more detail very shortly. See the first dip and the second dip. You might be tempted to think, oh, we did well those years. Actually, that's the 2008 financial crisis triggered by the US housing bubble and COVID. So turning on the top 5 emitters, or worst 5 emitters, you can see China, massive at the top, followed by the US, India, the Russian Federation, and then Japan. See, the US has been at one point the world's largest emitter. However, China, having sort of quadrupled its emissions in this time period, has very much taken the top space. India as well used to be a much less substantial emitter, now third greatest. When we turn on the percentages, China emits 30% of the world's emissions. And when combined, 3 worst emitters emit over 50% of the world's emissions, and adding in Russia and Japan to the top 5, they emit just about 60% of global emissions. So let's dig into China a bit more. 30% of global emissions. Why is this?
Well, containing about a third of the world's manufacturing is probably a substantial component, but
the Energy Institute also have data that they release on coal consumption and a whole bunch of other things: oil and gas production, consumption, flaring, renewables, and we're going to dig into some of these more in the future. But for coal consumption, China is in a league of their own. 55% of the global coal consumption being by China. India next up is only at 13 or just under 14%. The top 5 emitters are all high up on this coal consumption chart. Is that a coincidence? No, of course not. And Indonesia there, they're the 7th worst emitter. Iran are the 6th, but they're not actually on this. There is an abundance of oil and gas in their country, of course. But the headline is China can't get enough coal. Despite them having very ambitious net zero targets and being leaders in renewables, around 50% of global wind capacity is found in and offshore China. However, their huge energy demands just keep increasing. Notice some other interesting countries on this list. This is the top 14 coal consumers of the world. You might notice Australia and Germany. You might be surprised to see Japan and South Korea on there. So what sort of an impact does flaring have on emissions? This is looking at carbon dioxide emissions from flaring. Russia leading the top of the charts this time. Only the USA and China from the top 5 are also included in this list. So it appears that flaring has less of an impact on carbon emissions compared to coal consumption, the UK comes in at 1.8 million tonnes of CO2 from flaring, and that's a 0.55% contribution globally to flaring emissions. Norway, as our across the North Sea comparator, comes in at 0.3 million tonnes, 0.09% global flaring emissions. So this is a different graph showing the top section of the greatest CO2 emitters, again in million tonnes of carbon dioxide equivalent, and just for 2024. You can see after the top 5 of China, US, India, Russia, Japan, we have Iran, followed by Indonesia, Saudi Arabia, South Korea, Canada, Germany. I've highlighted the United Kingdom as well, coming in at 22nd place. We've made in 2024 0.81% of global emissions. In that sort of ballpark is Iraq and UAE and Vietnam, and just below the United Kingdom we've got Western Africa, whatever countries are grouped into that bracket, I'm not sure. Thailand, Italy, Kazakhstan. And this listing doesn't correlate that directly with economy size. The United Kingdom, for example, being the 6th largest in the world, only the 22nd largest emitter. And France, the 7th largest economy, doing even better than that. It's the 30th largest emitter. Scrolling down, just taking a look at the bottom of this list now, and we like to compare ourselves with Norway here at TROVE News because we share the North Sea with Norway. It's a very similar basin and resource size that the UK and Norway have had, and yet managed very differently. Although in this case, maybe not such a fair comparison, as Norway is the world's 31st largest economy.
Norway has a population size of around 5 million compared to the United Kingdom, which is around 68 million.
Here doing incredibly well, being the world's 73rd largest emitter at just 0.08% of global emissions, and we'll look into that in a little bit more detail as well. So now looking at total energy consumed by country, at first glance it might appear to be a pretty similar picture, with the top 5 still being the top 5. So the same top 5 worst emitters are the 5 countries that consume the most energy: China, US, India, Russia, and Japan. However, that's not quite the full story. There's quite a bit more to it than that. This is again looking at energy consumed by country, but we've got the different fuel types broken out. So you can see oil in green, gas in red, coal in black, nuclear in purple, hydro in blue, and renewables we've coloured yellow, and that includes, as well as solar, wind energy and other renewables. The EU is also included in this graph, although not a country, and that just shows that if it was a country, it would be the 3rd largest consumer of energy. Some other things you might notice: Germany, a lot of renewables, but also a bit of a slither of coal, oil and gas being dominant. France, having this large purple section, good proportion of nuclear energy. And countries that have an awful lot of oil and gas, like Saudi Arabia, Iran, UAE, you can tell even at this scale that makes up the majority of their energy use. Russia as well, very large proportion of gas. And then focusing on the black lines, looking at coal, obviously China, moving on from China, India, and some of these other big producers do just have a high reliance on coal. Some of the smaller consumers stand out though: South Korea, Indonesia in particular is having a high reliance on coal. Here's the United Kingdom coming in at 17th largest consumer of energy in the world, but we'll zoom in a bit further on that shortly. So let's focus in on the UK. This is looking at carbon dioxide emissions in millions of tonnes of carbon dioxide equivalent from 1990 through to 2024. You see from the UK it's decreased. In fact, it's almost halved, with a saving of around about 300 million tonnes of CO2 equivalent. And looking at the breakdown of our energy fuel in 2024, we're going to see majority is from oil and gas, small reliance on coal, small contribution from nuclear, 1% hydro, and 21% renewables. Then looking at the same graphs for Norway, it stayed pretty level. However, you'll notice the scale. In 1990, there were just over 30 million tonnes of CO2. The UK in 2024 was just over 300 million tonnes of CO2. So it really is a different scale. You might be thinking, why are the emissions quite so different comparing these two countries, other than we've already looked at economy size? But a big component is hydroelectric, which has far fewer carbon emissions associated to it compared to coal in particular, and then again compared to other fossil fuels such as oil and gas. Much smaller energy demand. The UK is requiring around 7 exajoules, whereas Norway is around 2 exajoules, whatever an exajoule is. So let's look at the big one, China. In 1990, just producing around 2,500 million tonnes carbon dioxide equivalent, whereas in 2024, we're up at over 12,000 million tonnes. That's an increase of 10,000 million tonnes of CO2 equivalent, and in that same time period, the UK has reduced its emissions by almost 300 million tonnes of CO2 equivalent. Looking in a bit more detail at China's energy breakdown, this is for 2024, and over 50% of its energy came from coal. You can see though, 11% of its energy coming from renewables. That's around 20 exajoules, which means that the UK economy energy demand could fit into that 3 times. And moving on to the US, the number 2 emitter. The US consumes half as much energy as China, and its emissions are less than half China's as well. You can see from 1990 there was an increase in emissions till about 2007, and then there's been a steady decline since then. And this is mainly down to the transition away from coal to gas. Of course, the Permian Basin and development of fracking has meant this plentiful gas resource for the US. Overall, it's a net decrease in carbon emissions from 1990 by 146 million tonnes. That's about half the decrease that the UK managed in actual terms. Much less percentage decrease, of course. And oil and gas are very much the main fuels for US energy. About 8% coming from coal, 8% from nuclear, 2% hydro, and 10% from renewables. So comparing just those 4 countries we've looked at in a bit more detail, we see Norway, a small country which has hydro resources able to supply most of its energy needs and therefore emitting very little CO2. Got the United Kingdom, reliant very much on oil and gas, and that's mainly imports now. Trying to be a global leader in terms of renewable energy, getting that up to 21% of the energy mix. China, with its huge dependency on coal, and the USA leaning into oil and gas. Another type of country that there's quite a few of are those smaller countries with vast reserves of oil and gas. For example, Saudi Arabia, here just replacing the graph for Norway. You see a 62% of their energy coming from oil, 37% from gas, 1% renewables. There's a lot of countries that are similar to that or flipped, with gas being the majority, including many Middle East countries such as UAE, Iran, Iraq, etc. So another thing this data release allows us to do is to compare 2023 to 2024 and see how each country has done regarding emissions in that time period. So first up, let's look at most reduced. You can see the smaller countries of Europe, when combined, have made the most reduction, followed by the US and Japan, which are of course 2 of the 5 greatest emitters, and Kazakhstan, Poland, Algeria, Italy. This could be very positive due to hard work, or it could be down to crises. As we saw on the global emissions chart, the only 2 periods that have actually dented the increase in global emissions year on year have been global economic crisis and COVID. We've highlighted the United Kingdom here as well, decreasing of that period. Then looking at those that have increased emissions from 2023 to 2024, the other 3 of the top 5 emitters are on this side of the chart with far larger numbers. China, India, Indonesia, Russia, Iraq, all increasing their emissions by more than the greatest reduction in emissions. So once you balance the books, we've got a net increase in emissions of 530 million tonnes of CO2 equivalent from 2023 to 2024. And that really is the conclusion from looking at the data. Global emissions are still going up. The top 3 emitters make up 50% of global emissions, and the top 5 just under 60%. And in 2023 to 2024, we saw a net increase in emissions of 530 million tons of CO2. So while some countries are trying to decarbonize, it's not offsetting other countries' increase in emissions. The global reliance on coal, although largely driven by China, is a problem for reducing carbon emissions and realistic targets. Though China are trying to increase all their energy sources, and they may be given preference even to renewables and gas as the fuels that emit less carbon dioxide. However, their energy consumption demand is really what's driving global emission increases. Thanks for watching. Give us a like, subscribe, ring the bell. We'll probably be doing some more videos on the data that was released by the Energy Institute. We'll leave a link in the description to where you can find the data, make your own graphs, and see what's actually happening on the global scale. Thanks for watching. Bye for now.